So one of the most basic questions we have about a function is to see if we can undo it. Whenever the most basic thing we do with a function is just stick in an input, calculate the output, stick in another input, calculate the output. That's really essential, but it gets a little boring, honestly. And we want to think about what other questions are natural to ask. And almost any time in mathematics, just to make something more interesting, just say, can I do it backwards? And functions are a classic example. So you've got this machine, it takes an input, we're going to call it X, so it spits out an output called Y, and we want to know if you give me the output, can I figure out what the input was? So two contrasting examples. Here's the sort of latest version of our tabular example that is copied down. We're going to call that F. In this case, if you tell me the output of the function was 2, I can look, there's nowhere else besides this column here that outputted 2. And so in fact, I know the input must have been a 5. Similarly, if the output is 1, there's only one place that appears in the outputs, and the input must have been 2. So just looking at the table, it's a little tricky. You can't just kind of look in order. You have to really double check everything. But you can figure out if the output was a 1, the input must have been a 2. So that's a nice property. In contrast, G here, I changed a few of these output values. If I say the output was a 3, the input could have been a 5, or it could have been a 1. If I say the output was a 5, the input could have been a 6 or it could have been a 0. I cannot tell for sure what the input might have been, okay? And so what we do is we say here that F is a one-to-one function, or just that it's 1-to-1, while G is not. Okay. A classic example of that in terms of formulas would be if f of x is just x squared. This is the most famous example of a function that is incredibly useful, very familiar, super easy to calculate. You just multiply a number by itself. This is not one-to-one. Oh, let me use yet another name. H, let's say, is the name for the squaring function right now. This is not one-to-one. Oh, and by abbreviation, you could say just 1-to-1, because, let's say, for example, minus 2 squared is 4, and it's the same thing as 2 squared. There's two inputs, positive and negative, that square to the same output. And that's why we get like a plus or minus, right? So when we try to solve, let's say, x squared equals 9, we have to put in this annoying ambiguity with that plus or minus, and that's because there really isn't just one answer. I don't know for sure which input was put into this function to produce the output 9. It could be plus or minus. And so when we get ambiguity in a solution like this, that is exactly coming from the fact that the original function wasn't one-to-one. We were trying to undo, the official word is going to be invert the function. We're trying to invert a squaring function. This just can't be done without ambiguity. Okay, so how does this show up on a graph? Okay, well let's graph y equals x squared. Very familiar graph, and we're just going to be just totally in love with this graph, and we're going to modify it a bunch. But this is just a parabola opening upwards. And what's going on here, the x value 2 produces the y value 4, but the x value minus 2 produces the same value, plus 4. And a way to visualize that is I'm going to look at the y value 4, a horizontal line, and we're going to see that that intersects this graph twice. So anytime you draw a horizontal line in an xy plane, you're just picking out all the same output value. You're saying, let's look at all y equals 4 points, just highlights those. And when it intersects the graph, those are actual outputs, actual places where the function has output the value 4. And then you just look down and say, oh, hey, here's the inputs that correspond. It's a really nice graphical way to try to do this undoing of a function. And if you notice that the horizontal line intersects more than once, then you discover there is no unambiguous choice for the input. So this is going to be a way to test that a function is whether it's one-to-one or not. So to say it explicitly, a function is one-to-one exactly when, well, the definition is that each output comes from, at most, it doesn't actually have to be achieved. Every output doesn't have to be achieved. Let me actually focus on that for just a second. Like for y equals x squared, for example, the horizontal line y equals -1, like down here below the axis, that doesn't intersect the graph at all. That's because you can't get a negative as a square. When you take the square of anything, it won't show up as a negative number on the output. That's not the main thing we're worried about right now, although it's an issue. What we're mainly worried about is, are there horizontal lines that intersect more than once? Okay, so this is saying each output of a function comes from at most one input, and we're not really guaranteeing whether there is an input that produces that output at all. Okay, and graphically, every horizontal line intersects the graph at most once. And we're going to be okay with some horizontal lines just not intersecting at all. That's a sort of separate issue. Okay. So let's see. Let's look at some of the other. Let's look at one of the functions we had in the previous video, like y equals f of x equals x cubed minus x. That's another one. You can see it kind of goes up and then turns down for a while, goes up again. A horizontal line right near the x-axis is going to intersect in fact 1, 2, 3 points, and so this is not one-to-one. So I'll just put that in, not one-to-one by the horizontal line test. Okay, and so that's a nice graphical way to verify that that is not a one-to-one function. What about a formula that would give it would be one-to-one? Let's just modify that example a little bit and then we'll be done. Don't want to make this too long. We're going to do this mostly in class. Let's say x cubed plus x. Okay. Oh, you know, again, the default here is it's just a little bit more than I want. Let's just go to like -2, 2. Okay. This now it's just going up, 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 up. It doesn't go up, down, up. Doesn't turn around like the x squared graph or the x cubed minus x graph. Here, I graph any horizontal line. We see that each one intersects at most once. So this will be an example where this is one-to-one. This is the graph of a one-to-one function. Okay.